awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Okay, example number 3. So here we have Atwood's machine. Okay, and it is a system consisting two objects connected by a string that passes over a pulley. So here we have a pulley. So the mass of the object on the left is capital M, 7 kg. So this is 7 kg. And the mass on your right side should be 4 kg. Okay, and then given that the mass of the pulley is 2 kg. So we are given the mass of the pulley, but we are not given the radius. Okay, so kita nak kira the moment of inertia macam mana? Sebab kita tak ada radius of the pulley. Okay, so jangan panik, teruskan sahaja tulis equation dengan betul. Nanti mesti kita ada cara untuk kita cancel radius. Okay, so now let's draw all the forces on the first mass. Okay, so since this mass, capital M, is heavier than the small m, so we predict that the motion should be in this direction. So A is downward here and A is upward. So kita ada dua pergerakan linear motion, which are capital M and also small m. So since the motion of the mass here is downward motion, so the direction of the pulley should be in this direction of alpha. Okay, so now let's draw all the forces on this mass. So we have W, M, and then we have T here. Alright, so let's put as T1. Boleh? And for this one, we have small m, and then here is T2. Alright, and then when we draw the free body diagram, so we try to draw all the forces on the pulley itself. So we're gonna have the first one, okay, here is T2, and here is T1. Okay, so here is R. Alright, so they are 90 degree. So the direction of torque for T1 is in this direction, which is in anti-clockwise direction. And for T2, torque T2 is clockwise direction. Since we already know that the pulley will rotate in anti-clockwise direction, therefore torque for T1 should be positive, since the direction of torque T1, okay, same direction as the direction of the alpha here. Okay, so torque due to T2 should be negative when you write the equation of net torque is equal to I alpha. Okay, so total torque is equal to I alpha. Alright, so in this case, so let's write, okay, and remember, always remember that A is equal to R alpha and alpha is equal to A over R. Okay, so now torque 1 is positive plus negative torque 2 is equal to I alpha. So A, what is the magnitude of the acceleration of the system? So we want to find the acceleration A, bukan angular acceleration. So bila kita nak cari A yang ada angular acceleration alpha ini, kita tukarkan expressionnya kepada, so alpha is equal to A over R. Boleh? Okay, so now let's substitute all the information that we have. So now torque 1 is equal to RT1 minus RT2 is equal to I alpha is equal to A over R. Okay, so we cannot solve for this one. Okay, but let's try to simplify the equation. Okay, so here we have RT1 minus RT2, and I, the moment of inertia is half mr squared. So let's write here half mr squared times AR. Okay, nampak dekat sini? We can cancel R. Okay, satu je kita boleh cancel. But on this side, we can factorize T1 minus T2 here. And we have MRA over 2. See? Okay, we can cancel out R here. Therefore, we can solve for A. Okay, tapi macam mana kita nak selesaikan A? Where A is equal to 2 times T1 minus T2 over capital M. Macam mana kita nak selesaikan? Kita tak ada nilai, yes, T1 and T2. Okay, but remember, we have two linear motions. Okay, sebab kita ada pergerakan. Di sini adalah linear motion. Di sini juga adalah pergerakan linear motion. Okay, so let's write the equation of linear motion from M1 and M2, capital M and small m. Okay, so we focus on the capital M first. So the motion is downward, means that the direction of W is the same direction as A. Okay, so we can write our equation, total Fy, okay, Fy capital M is equal to MA. Okay, so T1 minus Wm ke Wm minus T1. Okay, since they are same direction, means that Wm minus T1, okay, is equal to MA. Therefore, T1 is equal to mg minus MA. Alright, and for the second one, look at here, that T2 is the same direction as A, so T2 minus Wm. Okay, for the second part. So total Fy small m is equal to MA, so this one is small m. So T2, this time T2 minus W small m is equal to MA. Therefore, T2 is equal to MA plus MG. So now look at here, we have equation of T1 and also T2. Okay, so apa yang kita boleh buat? Kita boleh substitute dalam kita punya equation tadi. Okay, alright, so now let's start. I want to substitute equation T1 and T2. Okay, boleh tak kalau saya padamkan ini dulu? Okay, so we substitute here T1, okay, capital M G minus capital A minus T2. Okay, so kita substitute dekat sini. Okay, we substitute here. Okay, T1 and we substitute here T2. Okay, and equal to MA over 2. Alright, so mana yang kita boleh selesaikan, kita selesaikan dulu. And then mass here, actually this is the mass of the pulley. Kita letak MP supaya kita tak keliru. Capital M ada dua Okay, so this is the moment of inertia I. So means that the mass here should be the mass of the pulley. Okay, so the mass of the pulley, we can substitute, the value is 2. Okay, the mass of the pulley is 2, gantikan. So dia boleh cancel dengan yang bawah. Kan? Betul tak? Okay, so let's try to simplify the equation. Mg, capital M is 7 kg times 9.81 minus 7a, okay, minus small m is 4 kg plus 4 times 9.81 is equal to A. Okay, boleh? Okay, saya letak brackets ni. And then we try to solve. This one should be 86.67 minus 7a. Okay, and then minus 4a. And then minus 4 times 9.81, it should be 39.24 equal to A. Okay, so we can try to rearrange the equation. A ni terlalu banyak sangat A ni kan. Okay, so we can bring all A's in one side. So we're going to have 29.43 is equal to 12A. Therefore, A is equal to 2.45 meter per second squared. Okay, so we finish part A. Alright. And what is the tension in the part of the string that is connected to the block of mass M, capital M? Okay, so for B, we need to find T1. And for question C, we need to find what is the tension in the part of the string that is connected to the block of mass small m. That means this is T1 and this is T2. Okay, so since we have the value of A, which is 2.45 meter per second squared, actually we can find question B, T1, which is capital G minus mg minus ma. So m, we can factorize m, which is 7. So 9.81, sorry, this one is A. Okay, minus A is 2.45 meter per second squared. Therefore, T1 is equal to 51.52 Newton. Alright, and C, we can straightly find T2 from this equation. So T2 is equal to MA plus MG. So T2 is equal to, small m is 4 kg, A is 2.45 plus 9.81. Okay, therefore T2 is equal to 49.04 Newton. Okay, so we have answered all the questions in example number 3. So let's proceed to example number 4. Alright guys, example number 4. So let's continue. So here we have a 0.31 kg cart on a horizontal air track. Okay, and it is attached to a string. So the string passes over a disc-shaped pulley of mass 0.08 kg and radius 0.012 meter and is pulled vertically downward with a constant force of 1.1 Newton. Alright, now here we have a horizontal air track, okay, and we have a pulley and also a cart. Alright, so for example, here we have a cart. Okay, so we consider, since this is the air track, okay, so we need to consider that the surface is frictionless. Okay, and then we have pulley here. Alright, and then we have a string. And we pull the string downward with an external force of 1.1 Newton. Okay, so means that the cart will move to the right with an acceleration of A, and the pulley will rotate in clockwise direction with an angular acceleration of alpha. Okay, so question A. Okay, find the tension in the string between the pulley and the cart. So we want to find what is the value of tension here. Okay, so if we draw the free body diagram on the cart, so here we have T, which is outward from the cart. But if we draw the free body diagram, okay, on the pulley itself, for example, like this, okay, so we're gonna have two forces. So this is F1, okay, which is 1.1 Newton, straightly downward. Okay, so let's try to draw it straightly downward. Okay, again, let's try again. Okay, and then, okay, on the pulley itself, we have the second one, which is tension T. Okay, so this is the radius R. Okay, so let's calculate first the moment of inertia for the pulley. So I is equal to half mr squared, where the mass of the pulley is given 0.08 kg. Okay, and the radius is in meter, so tak perlu tukar apa-apa dah lah. Alright, and the moment of inertia for the pulley should be 5.76 exponent negative 6 kg meter squared. Okay, so we want to find the tension in the string. So now look at the card here. So now look at the card here. Here we have a linear motion for the card. Alright, so if we want to consider the motion of the card, it is a linear motion. Okay, and the direction is horizontal direction. So I will write total force X equal to MA. Okay, so tak ada friction. So the only force that in horizontal direction is the tension. So T is equal to MA. So saya tak boleh pun nak selesaikan. So we want to find T, okay, but we don't have value of A. Okay, so tak boleh nak gunakan equation linear motion. Okay, so we proceed to the second part where we need to use the rotational motion. Alright. So the rotational motion involve rotation of the pulley. So total torque, okay, this one is referred to the pulley only. Sebab yang rotate pulley je kan, is equal to I alpha. Okay, so this time look at here. So now look at here. Okay, so we have two forces that exerted on the pulley. The first one is external force 1.1 Newton. Second is torque. Alright, so since the pulley will rotate in this direction, so kalau kita lukis pula, okay, direction of torque for tension T in this direction, which is anti-clockwise, and the direction of the torque from the external force should be clockwise. Okay, so now antara torque due to the tension and torque due to the force F, siapa yang akan positif dan siapa yang akan negatif? Okay, so tengok balik pada direction of the rotation. Okay, angular acceleration dia clockwise. So kita nampak, oh, ini torque dia pun clockwise. So they are same direction. So now let's write the equation. So torque F should be positive, same direction dengan alpha, plus negative torque due to the tension T, and it is equal to I alpha. For here, we can change to A over R, since we know that, okay, where A is equal to R alpha, so alpha is equal to A over R. Okay, dekat situ kita boleh tukar dululah. Sebab apa? Kita nak hilangkan unknown alpha ni, supaya dekat sini equation number 1 kita ada A, equation number 2 pun in terms of T dan A sahaja. Kita tak nak ada alpha, ada A, ada T. Terlalu banyak sangat unknowns. So nanti you stuck untuk selesaikan sesuatu soalan. Okay. So torque for the external force. So RF sin 90 degree minus RT. Okay. And it's equal to I A over R. Okay. So this is second equation. Equation number 2. Tapi sebelum saya tulis equation number 2, saya nak simplifykan dulu equation ini. So this one, R, we can factorize. And I, okay, A over R. So now, since in equation number 1 here, kita tak ada value A. So saya nak rearrange equation from total torque is equal to I alpha ini tadi, sampai kita dapat satu equation of A. Okay, so ini saya bahagikan. Oops. Okay. Alright. So, A is equal to R squared F minus T, okay, over I. Boleh? So, this is equation number 2. Okay. So, kita boleh selesaikan. So, let's substitute in order to answer question A. Okay, so let's substitute equation number 2 into equation number 1. Okay, so I will write equation number 1 tadi mana? Ini kan. Tension is equal to MA. Okay, A sekarang kita akan masukkan R squared, okay, F minus T over the moment of inertia I. Okay, so dah boleh ke selesaikan? Bolehlah. Kita boleh selesaikan. Okay, so kita boleh masukkan Jadi kita boleh gantikan, okay, T is equal to, okay, M is the mass of the card. Okay, sebab ini kita cerita pasal pergerakan, okay, sebab ini kita cerita pasal pergerakan card kan. So, small m here should be the mass of the card, which is 0.31 kg. So, 0.31 kg, alright. So, times R squared, okay, times R squared is 0.012 squared. Okay, and then F minus T, F is 1.1 Newton minus T. T saya tak tahu berapa. Okay. Okay, and then I is 5.76 exponent negative 6. Boleh? Okay, so tak muat ni, saya terpaksa drag sikit ke sini. Okay. Let's continue here. So, I will try to solve this equation first. Yang ada nombor ni, saya selesaikan dulu. Ini bahagikan dengan ini. So, saya akan dapat, okay, T is equal to 7.75, okay, 7.75, 1.1 minus T. Alright, so T is equal to 8.525. Okay, kita darabkan dalam ni dulu. Minus 7.75T. Therefore, okay, kita kumpulkan T, okay, at one side. So, 8.75T is equal to 8.525. Therefore, T is equal to 0.974 Newton. Okay. Okay, and then for B, so let's read the question. We want to find, okay, the acceleration of the card. Okay, so from equation number 1, okay, we already know that T is equal to M, the mass of the card, times the acceleration. So we can find acceleration is equal to T over M. Okay, therefore, we can substitute T, 0.974, and the mass of the card should be 0.31. Therefore, the tension, acceleration A, okay, so the acceleration is equal to, cuba kira, berapa you dapat acceleration? Okay, so the acceleration is equal to 3.14 meter per second squared. Okay, so kena tahu unit ini adalah untuk A, bukan alpha. Okay, let's say soalan tu tambah. Soalan C, calculate the angular acceleration. Okay, so actually from A, so as we know that A is equal to R alpha, so alpha is equal to A over R. Jadi kalau soalan tanya angular acceleration, kita boleh cari saja 3.14 over R. So, R is the radius of the pulley, 0.012. So, actually, we can find the value of alpha. Okay, so alpha is equal to 261.7 and the unit is radian per second squared. Okay, so jangan keliru. Tengok soalan tanya acceleration ke soalan tanya angular acceleration. Okay, so finish example number 4. So, let's proceed to example number 5.